Okay, so where we left off was around here, talking about problems with the cloud and scalability and all that. Okay, so a typical problem why a business might need some service like the cloud. So suppose your organization's running a Super Bowl ad or some other major one-day promotion, and they expect, because of that, they expect like huge site traffic, way bigger than normal, 100 times normal, okay? So there are two options in that case. Number one, they could maintain the current system. Now, if they maintain the current system, what's going to happen? Well, it's probably not designed to handle 100 times the usual traffic level. So the site's going to crash. That's a problem. And then sales will be lost, right? Some people will try to make an order, they won't be able to. Other people will just see how the site is and say, man, this business can't even run a decent website. I'm out of here. Or the other option, expand the system. Well, if you expand the system, you have to buy and set up a lot of extra hardware, right? And that doesn't happen overnight if it's like 100 times your usual requirements. And you have to make sure it's all going to work at scale. And then afterwards, you're left with a bunch of mostly unnecessary capacity, right? You have this one-time huge traffic event, and then what? So obviously, neither one of those options is very good. This is part of why businesses turn to cloud operations, as clouds can easily handle that sort of sudden traffic surge that would be very expensive for an individual business. Now, the root of cloud is capacity sharing, right? So a cloud system is very, very large. It shares out some of that system capacity with any number of other businesses, and they all get to use a little piece of the system. So this is typically in the form of idle servers, extra network capacity, the ability to run applications, the ability to move data around through the network. So if the cloud system has this, they can, of course, run applications for other organizations, handle their website traffic, process transactions, right? Store their data, whatever. Now, sharing is very, very old. So it's just about as old as computers. So interesting fact, anybody know what the first computers were designed for? What they were actually used for? I'll give you a hint. It was World War II. For a long time, I thought it was weather because I'd read somewhere, heard somewhere that the first computers were used for predicting weather. But then I read somewhere else it was something different, something mathematical. Any guesses? Yeah, everybody always guessed cryptography, but that is a good guess, but that's not what it was, or at least according to the sources I read. Yeah. Anybody else? Payroll would have been a big guess, right? The U.S. Army was pretty damn huge in 1944. Anything else? Not payroll, though. Artillery trajectories, right? So the Army had lots and lots of heavy guns, and they said, well, if you're tilted at such and such and such and such and such elevation, and the wind speed is this in such and such direction, they cranked out lots of artillery tables so that the guys actually firing the guns would have a better shot of hitting what they were aiming at. So that's like the first thing they used computers for. Anyway, so back in the day, right, when computers were all kind of brand new in the 40s, they basically designed one machine to do one task, right? And that's kind of what it would do for a really long time. But eventually, computers got bigger and more powerful, and they didn't have to run the same application all the time, right? So like a business would have some big computer, and for like a few hours on a weekday, it would do payroll calculations. And then some other days it could do data mining. And then some other days, who knows what, right? Some kind of engineering simulations, who knows? So sharing dimensions in terms of time is a very old thing, right? It used to be that a computer would run one application at a time. You took the time to reset all the switches and make it run. You ran that application for a while. Then you had another time slot where you set it up for a new application and so on. And that's really old. But eventually that grew into the hardware sharing models, right? So some organization has a whole lot of hardware, way more than it actually needs for its own purposes. And so it could lease some of them out. Said, we have some spare servers, we have some spare storage and network capacity. We'll let you use some of it for a price. That's the hardware model. But eventually, and that, companies were doing that for a little bit. But what really made cloud blow up is this virtual capacity sharing. So the idea that the capacity is being shared, but it's not associated with a particular machine. So for example, some business wants to run its applications through Amazon's cloud, right? At any given time, it's going to have a slice of capacity on a whole bunch of different servers, right? For all the different applications it's running, they're going to be running on different servers, and it's going to have its data scattered around in Amazon's cloud, right? So data that is frequently accessed, it'll be in an easier to get to place. Data that's, basically historical, nobody's really looking at it, Amazon's going to keep it somewhere cheap, like on a hard disk. Okay, but you have the same effect. You can do all the stuff you want to do, but you're not tied down to renting particular machines. And that model actually saves a lot of money. We'll talk about why eventually. Right? So in next slide after this. So cloud started to really catch on around 2010. And you might ask, well, why didn't it happen sooner, right? What was really the limiting factor? Because, of course, resource sharing models, they've been around for decades, like since the 50s to some extent. Storage was available, right? Storage is never really the problem. Storage media is pretty cheap as these things go. And there were server clusters, right? I remember way back when down at Champaign-Urbana, they had some kind of supercomputer cluster you could get on. So yeah, the tools for cloud were all there. There was nothing to say that some business couldn't have offered the service to other businesses. But the reason why those other customers weren't that interested is you couldn't get a fast connection speed relative to the amount of data you were handling. So for a long time, in general, data volume has been growing faster than the transfer rate, right? The rate at which organizations accumulate data is more of a bottleneck than the ability to send it. So, they have a lot of stuff. Anything they want to do, well, let me draw a picture. I like drawing pictures. All right. So suppose you're some internal business, you're some business, and you have this internal system, and things are connected, all right? I don't know if anybody knows, but it is possible in a private secure system, you can get extremely fast data transfers, right? So organization and extremely fast data transfer, right? And the reason is because basically all you have to do is attach a couple cables directly to the computers, a couple high-speed cables, and burp, as fast as, the data can be sent over that little cable, it's as fast as it goes. It's, actually way faster than doing like a USB drive or something. So it is very possible internally to a business to set up systems so data circulates extremely fast. But the second you go to the outside over an internet connection, you run into a whole bunch of problems that slow things down, right? So number one, internet connection, right? Number one, different organizations sharing cable, right? Whatever the cable is, there's a lot of it, there's a lot of users doing it, and need to take turns, right? So what'll happen is at various points through the data transfer, your data will get held up while somebody else is, taking their turn to use the system. Number two, converting data into packets, right? And making sure each packet is correctly sent and received. So what happens is you don't just send a big slug of data in one shot over the internet. What they do is they chop that big slug of data into tiny pieces called packets. Each packet has like a maximum size of like 1.5 kilobytes. And at every point where it's being sent over the internet, somebody says, hey, is it okay if I send you something? And the other device says, yeah, I'm ready, go ahead, send me something. And then that device says, okay, here you go. And then the one that receives it says, okay, thanks, I got it. And it's called a four-step handshake, four-way handshake. And it takes time, right? It takes time faster than just, throwing data down a cable. So all that sort of stuff, yeah, that adds on delays. And then finally, security checks, right? All the different security checks you got to do, the encryption, the decryption, the different mechanisms that the system has to make sure that people aren't looking at data they're supposed to. All those sorts of things slow down the data transfer a whole lot, right? And of course, the other thing is that the same cable that, you know, is going out of your router is not the same super fast, high capacity cable that you could use to just directly connect devices. So different hardware, different rules. It's a lot slower to send stuff over the internet. Okay, so businesses looked at that, and consequently they said, well, yeah, we have a lot of data, but as long as we can process it internally in our own super fast system with fast connections, it's not a big deal. We can move it around from one machine to another. It's all right. But as soon as they go outside the organization, remember the other day we talked about how it could take something like all day to download, you know, a gigabyte. Well, it takes like a minute to download a gigabyte file, and it takes like basically all day to download a terabyte of data. That's the sort of problem that businesses had to deal with, right? So circa 2000, if a business had a gigabyte of data, it was going to take a very long time to download that much, right? So it's nice to say, yeah, somebody's handling the data problems for us, but if we want to pull that data and do some analysis on it ourselves, it's going to be a long wait. All right. But eventually connection speeds got relatively fast, you know, compared to the amount of data that was out there. And a lot of the organizations, cloud systems like S3, for example, they provide analytics, you know, on their platform already, so you don't need to download so much. All right. Now, cloud is much more than machine replication. So let's talk about what machine replication is. That means you're making a copy of your system in the cloud. Essentially, you would say, you know, maybe our system uses 32 servers, and those servers are using this particular arrangement of applications and are holding such and such data. And basically, you make an exact copy of whatever's under your roof on a set of very similar machines in a very similar configuration in the cloud. Now, with that, you can save some money. There are some economies of scale. Obviously, the cloud providers are very large, so they're getting the bulk purchase rate on servers and other hardware. Also, you know, some things just kind of create scale savings naturally. For example, it doesn't cost much more to build, you know, a facility to hold 10,000 servers than it does to hold 1,000. And in terms of physical security and in terms of how many network administrators you need, right? You're not adding that much in terms of cost over what it would take to run a smaller system. So you are going to save a little bit of money. But the downside is the cloud provider has less control, right? So number one, if you're doing virtualization where you say you give everybody a slice of whatever hardware they need when they need it, in machine replication, you have to rent that whole batch of servers, right? You have to rent like all 32 servers to mirror your system that you already have. And because you're renting those servers all day, every day, whether you really need them or not, you're going to pay more than if you just use the system capacity where you needed, where and when and where you needed it. So that's going to end up charging you a lot higher rates than they could be. Number two, if you're making a perfect copy of your system in the cloud, you're missing some possibilities for the cloud to arrange your data better, right? Now, it's possible that you have your system optimally arranged for whatever particular set of hardware you're using, but in any organization, there's always the fact that some data is looked at often, most data is hardly looked at all. And so, you know, the cloud can take advantage of that to store data in various different kinds of media, make it more or less accessible, and, you know, try to provide a reasonable balance between performance and cost. So cloud systems work better with more flexibility. Your applications can be broken up and their components deployed across servers. Okay, so I talk a little bit about this and something that I hope everybody will understand. So suppose your organization uses 1,000 licensed copies of Microsoft Office. Okay? And each copy has 5 applications, and each server can run 100 application instances. Okay? That means 5 times 1,000 applications total divided by 100 applications per server equals 50 servers. You're going to need 50 servers, right? If you do machine replication. Okay, I say in the machine replication model. So for example, suppose you like have, whatever, 1,000 workstations. Each workstation has a complete copy of MS Office, right? Now, in the virtualization model, the cloud system might recognize that on a typical day, at a typical moment, your organization only needs about 1,000 application instances total, right? Some mix of Word and Excel and PowerPoint, SharePoint, Access, whatever. But on a typical, you're not using every application, every license. So the cloud keeps your typical requirements ready and can spin up new instances if you need them. But on average, you only need about 10 server equivalents, which is going to save you money relative to 50 servers always available. Does that make sense? I hope that makes sense. Basically, you could make a perfect copy of your system in the cloud, but you're going to miss out on some definite opportunities for saving because maybe you don't need everything that you have under your roof. You don't need it all the time. Okay. It just happens to be there. All right. Now, cloud attributes. So, obviously, if you have a cloud system, if you are a cloud service provider, obviously you need some excess capacity, right? Because you don't want customers showing up and saying, hey, I'd like to, join your cloud service. And you say, sorry, we're full, right? That's not a good business model. So, of course, cloud systems require excess capacity, but they need some other things too. Number one, flexible contracts, right? So, if you have this kind of model, right, if you have your machine replication model, you're not going to need much in the way of a flexible contract there because the organization has rented out a specific number of servers for a specific time interval, and they know it's going to take a little bit of time to scale that up or down, right? You're not going to instantly change it in machine replication, right? You'll have to redesign the system under your own roof before you can really figure out what to do on the cloud side of things, or you'll at least have to have a new redesign plan. Whereas in this one, in virtualization, right, there's always the assumption that you have what you need when you need it. So maybe your day turns out to be an unusually busy day and you need like 25 server equivalents on average through the day. Or maybe it's a quieter than average day and you only need like 4 server equivalents. For the virtualization model, the cloud system is always going to have to continually track what you're using, and flexibility is therefore completely built into it, right? Because if you say, well, we're only going to use what we need when we need it, then somehow the cloud system has to track what you're using and charge you for that, not charge you some flat rate. Okay. The other thing, of course, easy, fast, reliable communication, right? So in practice, that means some kind of high-speed internet connection, right? There are other connections that are off the internet, but basically businesses like to do their work over the internet. It's just a lot easier to keep everything in one system like that. And, again, has to be easy to use, has to be fast enough, has to be reliable, right? Your cloud system has to always be on, has to be secure, stuff like that. Now, cloud services have 5 essential attributes. We'll talk more about these. We'll wind it down with service-based architecture. So let's go ahead. We'll get into that. Okay. So the main benefit of using cloud, right? The big reason why businesses switched over to it is that operating costs are lower. You save a lot of money. Basically, you only pay for the capacity you need. You don't have a lot of extra hardware to meet peak demand sitting around and gathering dust. And in fact, cloud provider economies of scale bring down the cost for all users. We'll talk about that on the next slide. Some additional benefits, just performance type stuff. Number one, vastly reduced risk of traffic overload, right? So Amazon, for example, has something around the order of 1 million business clients using its cloud. And obviously, any one of those business clients can't be a very huge share of Amazon's total system capacity. So, if one of those businesses experiences like a mad, you know, burst of activity and needs 10 times more system resources than it usually uses, that's shruggable to Amazon, right? They probably won't even notice. But yeah, for what would be a big deal for the business might overload them. Amazon's going to be like, oh, yeah, we got to bring on a few new servers for those guys, whatever. Number two, automatic backup and recovery. Now, of course, this is something that businesses can do themselves. And of course, for a long time they did. But remember, most businesses fundamentally don't want to be in the IT game, right? IT is something they use. They don't want it to be a system that they have to manage and have lots of experts on hand to do this stuff and design backup and recovery procedures themselves. It's much easier to let the cloud do it, and the cloud systems are pretty good at it. They could probably do it cheaper than the business can, and they'll do a better job of it. Similar thing for delegating hardware and software upgrades, right? Anything that had to be upgraded back in the day, of course, that was something that businesses would do themselves. But really, they didn't want to be in the IT game if they didn't have to be. So when they're on the cloud, that means that it becomes the cloud's problem. It's built into the cost that there are going to be occasional hardware upgrades. There's going to be software patching. Interesting thing about security. So one of the things when I say cloud systems generally have better security than the businesses who use the cloud services, in most cases, when a hack happens or a breach happens through some sort of security vulnerability, usually the mechanism for fixing that vulnerability was in fact available to the business, right? They might have gotten it as part of a bundle of patches, but they were waiting for the next cycle because they don't want to update things continuously. They like do things in a batch at the end of the week, or maybe one department in a business had done it and the other department didn't for some reason. Maybe there was some kind of user failure where they had the patch, but then they didn't check and see that all the machines got patched, whatever. So, but the cloud systems, they're much more consistent about that, right? Because it's really core to their business that they are secure. And so the last point, almost certainly better security at a cloud operation than at one of its business clients, right? It's not an absolute metaphysical certitude, but cloud systems do not get hacked very often. Ordinary businesses get hacked and breached quite often. All right. Now we'll talk about economies of scale. So your typical cloud providers are very, 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 very large, right? Tens and tens of thousands of servers. And they also, the big ones, tend to have a diverse mix of clients. So not talking about demographics there, talking about their system needs. So what happens, a big cloud system like Amazon, they have some business clients here on this side of the world. They have some business clients on the other side of the world. They have a sprinkling of businesses from all sorts of different time zones. And some businesses are busy in the daytime, not so much at night. Other ones are busy at night, not so much in the daytime. They have different seasonal patterns. Some are busy during the week, not on weekends. Others could be the other way around. Whatever. The net effect is this. I'm going to do this in Excel. Let's bring up Excel. I'm going to do it better than I did before. Okay, so we're going to do some dice rolling, okay? So this first one is going to be equals int 6 times rand plus 1, right? We're rolling one die. Now, we're going to do that. Okay, hold on, I can just copy this. Okay? And we're going to do that twice. Here, we're going to do that twice. And here, we're going to do that twice. And here, we're going to do that twice, right? We're going to make a very visible understanding of why scale things tend to balance out. All right, so here we have, all right, 1 die, 2 dice, 4 dice, 8 dice, 16 dice, 32 dice. Okay? All right, let's even that out. We'll even you out. Now we're going to find the average. Okay? So equals average. We're just going to do this for all of them. B2 to what? B34? Is that how far it goes down? 34, yeah. Oh, you're not letting me do it. Okay. Oh, B3 to 34. There we go. Zoop. You can see as I flip this, right, there's a lot of variability on the small numbers. There's not much variability once you get to like the 8, 16, 32 range. It's all about 3.5, right? It might be as high as 3, might occasionally go over 4, but you know, this number in particular is not drifting very far from 3.5. Okay? Now, the reason is these dice are uncorrelated, right? They're all thrown independently, and on average, it's going to balance out. If one die rolls high, it's equally likely that another one's going to roll low, or vice versa. Same kind of thing. So, in terms of demand, what the cloud systems see, right? So here's going to be, I'm going to draw one chart for one business and another chart for another. Okay. So a single business might have its profile of activity look something like this. And we're going to assume that business needs to have this much hardware capacity on hand. So, right, so this will be, you know, system requirements. Okay, so this is how much they need based on actual activity, but the system has to have a little bit above that for a safety margin, right? If you take the volume, the area of this, and divide it by this total area, it's going to be something around 15%, right? So what that means, roughly, for every one server equivalent of capacity needed, the business must have 6 or 7 actual server machines. Because why? Because it's not going to need them all the time, right? But they need to have, you know, if you're going to need maybe 5 on average here, you got to have like 6 or 7, you know, and you're not getting rid of them for the rest of the day. They have to be on your premises all day. Cloud system, on the other hand, cloud system's going to look more like this. Yeah, they're going to have a little bit of busy time. They're going to have a bit of a slowdown, whatever. It's going to happen. But a couple things. Number one, the demand profile itself is pretty stable. So we'll put this in green. Demand is more stable due to size, right? When you're talking like Amazon scale, the amount of traffic you have in a given day is not going to change on a dime. So it's automatically going to be stable, so you don't need as much safety margin. Safety margin. Also, what else? The system is closer to busy more of the day. Okay, so again, ordinary single business, they're going to have some times where it's pretty much dead. Cloud business, yeah, they're going to have slower times, but even their slower times are still going to have a fair amount of activity going on because, again, when some businesses are busy, others are not, and vice versa. So, real world numbers, for each server equivalent, Amazon needs around 1.5 actual servers. So this is how they save money, right? This is how businesses save money going to cloud. They say, look, if we were going to provide the same level of capacity, you know, one server equivalent, we need to buy 6 or 7 machines. If we're getting it from Amazon, Amazon only has to have like 1.5 server machines to provide that. So even though Amazon's making a lot of money on this, they're still providing the service for much cheaper than the business could do it for themselves. Okay? Does that make sense? Would you like to know more? All right, so the reason is Amazon's not providing a cheaper level of service, you know, because they have some fantastic technology. They do have good technology, but it's, you know, the same machines that anybody else is using. They don't have some special network magic that nobody else has. It's just they're the biggest. And the fact that they are very, very big makes their demand profile look like that, and they can save a lot of money based on that relative to what it would cost a business. Okay? All right. So, and again, this is another case, scale advantages compound, right? Amazon is big, it solved its scalability troubles, so it gets a lot of advantages from that. Competitors, they are not as big as Amazon, so they can't smooth demand quite as well. Also, various types of overhead costs become relatively small for Amazon. Again, things like the physical facilities, things like security personnel, things like network administration, all that. Again, you don't need to add twice as much in terms of physical security when you double the number of machines. And last, cost advantage. Because Amazon is very, very big and has smoother demand and these scale advantages, they can offer the same service cheaper than its competitors. So they can either A, make more money by charging a similar rate, or B, try to capture more market share by undercutting their competition. Either way, they're kind of denying these scale advantages to their competitors, right? Amazon will really have to drop the ball for somebody to come along and boot them from the top of the cloud stack. All right. Okay. Now, as far as cloud models, there's 3 major ones and 1 minor one. So the first one, public cloud. So public cloud means cloud provider offers a service. Anybody can show up, create an account, pay money to use the service. The standard for public cloud is that your data is not guaranteed to be isolated from other users. I mean, of course, the cloud doesn't want some random person going in and peeking at your data, right? But what happens is something called co-tenancy. So you don't get the server all to your own use. So there's going to be a bunch of other users in the world potentially looking at the same server that your data is on. Now, again, cloud tries really hard to make sure that those people can't see any of your data. But there have been some famous data breaches, notably the iCloud hacks around 2010 that I know some of you have heard of. But so these risks happen, right? I can't recall if there have been any major ones in a while, but I don't know. Maybe I just haven't been paying attention. Also for public cloud, you can get premium options for isolation or even where your machines are physically located. So again, if you are very concerned about other people having access to your machines, you can, of course, rent out specific machines that are solely dedicated and reserved for your use. But it's going to cost you extra because instead of reserving a slice of that machine's capabilities, you're going to have to reserve the whole machine and you're going to have to pay that rate whether the machine is busy or not. Okay. Now in private cloud, the customer has the exclusive use of the cloud service, right? It's one cloud and only your organization gets to use it. Now, typically, private clouds happen when the organization itself owns the cloud. For example, Facebook has its own cloud, Google has its own cloud, Amazon has its own cloud, YouTube has its own cloud, right? But if you really wanted, you could have your business call up Google and say, hey, Google, can you set up a private cloud for our organization? And Google will say, yeah, we can do that for you. It's going to cost you some, but yeah, we can do that. That's part of our package of services. So it will be more secure, obviously, if you're the only organization that has the keys to it. And in some cases, it might be necessary to have that sort of security for legislative compliance. There's certain kinds of data, like financial account data, that has to be kept super secure. But it's also going to be much more expensive than the public cloud, right? Because why? Because you're going to, in fact, own that whole cloud yourself. So the opportunities for paying for what you use when you use it are not really there. You have to build up the whole system, and that's not going to turn on a dime, right? You're not going to go from having 10 machines one day to having 1,000 machines the next day and then back down to 10. You do that with the public cloud because virtualization happens there. Private cloud, it's harder. It's going to be slower. All right. Now, hybrid clouds exist, various combinations of the above. So what that would mean is, for example, an organization might keep some of its data that's super secure in a private cloud or in some sort of elevated secure part of a public cloud. Like if you're a banking operation, right, you might keep your financial account data super secure like that. But your marketing materials, right, you made ads, you made promotional stuff, whatever, You have recordings of various non-controversial meetings that you've had for your business. Those you might just store wherever, right? You might not care. You say, what, are we concerned that some hackers are going to go in and see all of our TV commercials from 2019? It's not really a major risk. So hybrid cloud, some kind of mix of those. And it makes sense because, private cloud is generally more expensive, more secure, what's called often a virtual private cloud, as that more secure area of a public cloud. That's going to be more expensive. So, you pay for what you need when you need it. The last one's community cloud. Now, community cloud's kind of a strange thing. The idea, 20 years ago, a lot of people thought this might be a really big thing. And it exists, but it's not really huge. What it is that a group of organizations might create a cloud system for some project that they're jointly working on. For example, if you have a bunch of businesses working together to design a major new product, they might set up a cloud so they can share data more easily with that. Or you might have some government agencies, right? Like some joint operation between Homeland Security and Department of Transportation and the military. They might have some joint project that they're working on. They set up a community cloud so they can share information easier. Now, again, it hasn't turned out to be that big of a thing yet, but just like ERP, 30 years ago, ERP was just for the really, really, really big businesses. But since then, it's trickled down to medium and small businesses. This community cloud too, right? The costs come down. This might be something that becomes more widely used as the cost of hardware generally and cloud systems, keep on falling. Might be something that we see more of. All right. Now, elastic leasing is pretty straightforward. Just means that users can change their resource allocation at fairly short notice. Right now, in a public cloud, if you're paying for what you use when you use it, this isn't a big deal. If you're having an organization set up a private cloud for you, then it becomes, a little tougher. They don't want to spend all that time and money setting up a private cloud for you, and then you say, oh, and by the way, we don't need those 1,000 machines anymore. We'll just have like 3 now. They're going to be like, what? So, anyway, if the cloud provider is very, very large, having that sort of elasticity where you can ramp up from 1 to 100 or scale back down from 100 to 1, it's not going to really be disruptive because for every business that is using more resources in a given interval, there's probably another one using less resources. All right. Next thing, metered connections, monitoring what's going on. So if you have elastic leasing and you're giving businesses the opportunity to only pay for what they use when you use it, obviously you need to track what they're using. That's what this metering is. So if you have a fixed set of resources that you're using in your cloud, right? Some machine replication model, you've booked like 20 servers. And so you're just going to pay for those 20 servers. There's not really much to do beyond that. But other times, if you're just paying for what you use when you use it, they're going to look at how much network traffic did you generate? How much storage capacity did you use? How many CPU cycles did you burn up running your application? Stuff like that. And the cloud service is going to, add it all up and send you the bill, basically. Okay. Now, the last topic we want to talk about today is service-oriented architecture. Okay, or SOA, rhymes with boa, like the snake. Okay, so SOA. So what a service is a small and independent application. So in this course, we've spent a lot of time talking about application interfaces, right? Different applications sometimes have to exchange data. So service-oriented architecture is where you have small applications that exist just to exchange data of one type. And then you build your applications and bigger applications and business processes around those small units. So we'll talk about that for Amazon. Suppose you are selling something through Amazon, right? You, the seller. That's really weird. I don't know why I have that box here. That's weird. Okay, strange. All right, so you are the seller, and then there's Amazon down here. Okay? And if you want to sell something on Amazon, what would be the first thing you do besides, having an email and setting up an Amazon account and stuff like that? What do you got to send to Amazon to sell a product there? what would you think you would have to send them? Does Amazon know what you want to sell? So you'd have to tell them, right? You'd have to send them some object about the thing you're selling. Okay. So you send Amazon some data object, you know, product and relevant data, right? So that Amazon can make a web page, a product page out of it, and know where to send payments and all that sort of thing. Now, suppose someone actually clicks, adds your product to their cart and tries to buy it. What has to happen then? How would they go about buying something on Amazon? Would they put some cash in an envelope and send it in the mail to Amazon? Then how would they do it? How do people pay Amazon mostly? Credit cards, right? So Amazon would need to send data objects to some credit card company. Let's say Visa. Let's say we start with Visa, okay? And anytime a transaction happens, Amazon has to send a bundle of information, right? A transaction object, which is going to contain things like the items, price, card numbers, right? The CCV, card holder. I think that's one word these days, card holder, address, and whatever else, right? Whatever else they need to send, that's fine. We don't know. They send a bunch of stuff. Okay? And then what does Visa say when it gets all that? It says one of two things. Yeah, yes or no, right? Approved or rejected, right? It's going to be one or the other. So that's when we say applications are exchanging data in a standard format, standard interfaces, right? Amazon expects to receive a data object from you to create the web page. The credit card company expects to receive a bundle of credit card transaction information so they can process that transaction. Amazon expects to receive back from Visa thumbs up or thumbs down. Okay? Standard formats. Now, the neat thing about service-oriented architecture, imagine this. If you have many credit card companies, like say MasterCard and Discover, I don't know, Players Club, whoever, right? Amazon can send potentially the same transaction object to any of them, and it'll work, right? They don't have to radically redefine their transactions to work with different credit card operations. They should all have a fairly standard interface that they all use. Likewise, they all send back a fairly standard thumbs up or thumbs down on any transaction. That means it's very easy to include new credit card operations in this, right? Likewise, every one of these credit operations, they're doing transactions with other companies besides Amazon. I mean, sure, Amazon's big, but Amazon's not the only one. So any of these other companies, they can certainly, right, interact with the credit card companies. Likewise, Amazon is dealing with many sellers, not just you. And it's nice that Amazon has set this up so they can deal with any number of sellers, right? Amazon doesn't really care which seller is sending them the bundle of information. Who the person is already bundled up with this data object, right? Has your like secure code and whatever, so Amazon knows it's actually you. And that all works. Okay, so again, neat things about service-oriented architecture. Number one, services can be located anywhere, right? Doesn't matter where they are, doesn't matter who they are. As long as you send the data in the proper format, the application that receives it can process it correctly. Number two, easier modification of services and applications. So suppose Visa wants to implement a new fraud detection algorithm. Is Amazon going to have to change any of its procedures? No. And isn't that a wonderful thing? Right? Because periodically they are going to tweak their algorithms and look at some different stuff. But because all of that doesn't affect the interface, right? Amazon can still send them the same data in the same format and the transaction will still get processed correctly. Amazon doesn't need to know about the changes in the fraud algorithm. And any one of these different credit card organizations can have their own different separate fraud detection algorithms. and it's fine. It doesn't mean Amazon has to do anything differently, right? Same as Amazon doesn't need to know the exact process that you're going to use for manufacturing your products that you're selling on Amazon. It just needs to know that you're there and you're going to send them out when somebody orders. Okay, so that's a nice thing. And last, reuse without modification, right? So if you just want to reuse something, basically create a duplicate clone of something, suppose Amazon makes another data center. Well, they can use it in pretty much exactly the same way, right? So we can just make a whole nother clone of Amazon, put it over here, right? And that one can interact with the credit companies in the same way. So it's very easy. Other components that are out there, you can just reuse them in different places, different environments. Okay? Service-oriented architecture is a neat thing. We'll have more to say about it on Monday, but have a good weekend. Bye, everybody.